Next, we're going to cover how to go from the logical view to the physical view. Here is an ER diagram for an art gallery database. It's in crow's feet model. Here, things I want to point out are that we have some alternate keys identified. If you recall, when we were talking about keys, we had surrogate keys and primary keys and foreign keys. Do you recall the term candidate key? It is possible for one or more sets of fields to uniquely identify the record. That makes that key a candidate key. When we went through the process of normalization, that was very important to identify the candidate keys. In artists, for example, the combination of first name and last name makes an alternate key because it was decided to use a surrogate key of artist ID as the primary key. But we're not going to have two artists with the same name. We have that also for email. In this ER diagram, and this is something you will have to do also, is when the relationship is one-to-many, we're going to take the primary key on the one side, which is customer ID here, and add it as a foreign key on the many side, and this is identified here as a foreign key. Here again, we have a one-to-many. Work ID is the primary key. It's going to become a foreign key on the many side. Artist IDs on the one side, work IDs on the many side. Here is a foreign key. Here we also have an alternate key of the combination of title and copy for a work. And then this was a many-to-many, and the composite entity has been added, as you see, to convert the many-to-many. An artist can have many customers. A customers can purchase many artists. And here is the customer artist composite entity, bringing in the primary key from customer and the primary key from artist as the composite key in this new table. So from here, what I would do next is to map this into relational notation. So you just start with your first table. And we have customer, and in parentheses, we're going to put in our field names. Customer ID is our primary key. We're going to go ahead and bold and underline that. And there are no foreign keys here. I'm going to make a note that we have email as an alternate key. And now I'll go ahead and complete our relational mapping. I've stepped through every one of the entities and created the relational notation. I've used underline and bold for the primary key. It's pretty standard to put the primary key first in the list of fields in the table. And I've italicized the foreign keys, and it's standard to put the foreign keys at the end of the list. In addition, when I was looking at this field medium could be like watercolor, oil, charcoal. I thought that needs to be a lookup. I hope you agree. So I've created a very simple medium underscore lookup table. So the contents of medium will be things like charcoal and oil. And what that does is it forces data consistency in the work table. So someone can add oil colors when they're essentially the same thing. It'll be oil is oil because that's what I have in the medium lookup table. The next thing I want you to do then is to create a table where you thought about what are the data types, what are the alternate keys. Just notate all that before you start your SQL. Before we even start that, however, let's talk about data types. The main thing that you are doing when you create a table is you will indicate the field names and the data type for each of those fields. If you've ever done any programming, you're aware of variables, and when you declare variables, you need to indicate the data type for that variable. This is exactly the same. And while there is an ANSI standard for data types, in actuality, you will need to learn the data type for the DBMS that you are developing for. What we see here are the data types for SQL Server 2012. In general, regardless of the data types, There are four major types of data. One is numeric. Generally in numeric, you can break it down to integers and floating or decimals. But even within that, integers in SQL Server, for example, could be big int, just regular int, small int. All of this decides how many bytes you want to store that number in. And here are our decimals and money. So quite a range here. The next type of data relates to date and time, and in actuality, date and time is stored as a number, but you don't have to worry about that. That's how math gets done. So here are some of the date time fields in SQL Server. Next, we have our characters, our alphabet. A group of text we call a string, and a lot of times you might indicate how many characters or how many bytes are in that string. So this is what we have in SQL Server. And then some other types of data you might have are things for images. Some databases actually call that a blob. Here are some various other data types, especially as we get into storing videos and images, etc. This table contains the list of data types supported in Access if you created the table through the grid, and the equivalent data type names you should use in your SQL if you create it through VBA. Notice that some of the data types are not supported, so don't use those values. So I went ahead and wrote some VBA to test this. I have a procedure called another table, and notice that I've used the data types that were indicated in that table I showed you and executed without error, thank goodness. And here is the name of the table created, and you can see the data types that were created with that SQL matches the data types in Access. This one shows a number, and notice the field size is integer, so that did create an integer when I used the short data type in SQL. So I'll post that table that you can use for a reference when we're going to the next phase of physical design. The next step is to create the data dictionary. The author does this in Chapter 8. He has this ER diagram on page 360, and he creates the data dictionary. Here is the data dictionary on page 365. This would work well if I had a book and can turn it around, but I copied and pasted it into Word so we can look at it. Here is a sample data dictionary from that ER diagram. He's listing the table names, attribute names, a brief description of the content, the data type, the format, if there's a special format for that piece of data, the range. Some numeric data has a range of the maximum number and the minimum number, whether or not it's a required field, whether it's a primary key or foreign key. I would also add that you should indicate whether it's an alternate key, AK, and if it's a foreign key, what table that foreign key references. So this is the author's example. I've modified the data dictionary from the author's example by putting the format, range, foreign key reference in the remarks. The required, I wrote null status because you're going to write null and not null in the SQL. I would like you to look up the Access SQL type and use that data type here. So we're going to do this for artist. I'll write data dictionary artist here. What I'll do is create a different word table for each entity. So here we have our artist, and looking at artists, I have artist ID, and that is a primary key. So I'm going to type PK here, and in Access, how are we going to get that key? Should it be just a surrogate key? I'm going to indicate that this is going to be a surrogate key in my remarks. And the data type in Access for a surrogate key is auto number. And all primary keys are not null. Next, I have the last name field. What's the largest number of characters in a last name? I don't want to waste memory. I don't want to waste storage. So I don't need to make it 255 characters. No one's last name is 255 characters. But you don't want to truncate it by making it too small. So I'm going to use varchar and 50 for the size. Notice that the combination of the last name and the first name is an alternate key. So I'm going to write AK1 here. If it's an alternate key, I don't want it to be null. I'll go ahead and do that to indicate that those in combination are going to be the alternate key. Same consideration for first name. I don't think anybody's first name is more than 30 characters. AK1, not null because it's part of an alternate key. And my next field is nationality. And now that I'm thinking of it, I would probably make a nationality lookup table. So no nationality is going to be more than 50 characters. Maybe I don't know the nationality. Next we have date of birth. And I'm going to say I might not know an artist's date of birth, but obviously that's a date field. It's not a key. I'm never going to look somebody's artist up by birth date. And let's do a date deceased. And I might not know that either. Both of these should be null. Now going back and looking at the author's example for the date fields, he did do a format for the date fields. So I'll enter a format for the date fields. Now you could enter a range too. I'm not going to do that for these fields. Let's repeat creating the data dictionary for work. Here is my ER diagram and my relational notation. We have our primary key work ID. I think I will make that a surrogate key. And if you recall, surrogate keys in Access are auto number, and primary keys cannot be null, so I'll write not null there. The next two fields, if you look in the ER diagram, are alternate keys. Title is unique, but if the title is a print or a lithograph, there may be multiple copies. So the combination of title and copy is an alternate key. A title is character. Let's say 35, alternate key 1.1. And as part of an alternate key, it cannot be null. Copy, you might think 1, 2, 3, 4, we should make it a number. However, I have a rule when I create databases. If it looks like a number, but you don't do math with it, maybe you want to make it a character instead. Let me give you an example. Zip codes. 00512 is a zip code somewhere in New England. But it looks like a number, but if you make it a number and you went to print it out, those leading zeros will be truncated and what will print out will be just 512. So by making the zip code character, I never do math with my zip codes. I'm not truncating those leading zeros. I am going to make this a varchar. Well, there's never more than 999 copies, so we'll keep that at 3. And that is part of the same alternate key as alternate. It's part of a candidate key. You will not want that to be null. Median. I will assign that a text field with 35. It's not a key at all. Maybe we don't know the median. It's not an alternate key. I don't have a format for it. Let's go with description. Description might be quite lengthy. The description might be pulled for a website where you display information about a piece of work. So we would want in Access the memo field. And coming back to our table, the memo field, we can use long text. Looks like we could use memo also, but long text should work. And our description, not a key. Maybe I'll just describe work of art. I have the artist ID, and that is a foreign key. So I have to make sure that agrees with the data type in artist, and the data type's an auto number. Now, when it's a foreign key, so an auto number is 1, 2, 3, 4, 5. It's an integer. You cannot make the foreign key an auto number, but you need to be aware that an auto number is an integer. So I need to make artist ID an integer. And taking a look at our table, an integer, I would probably use long for that. And we'll indicate that that's a foreign key. Do I need to know the artist? Well, let's take a look at our ER diagram. Notice that the minimum cardinality right here, this is saying an artist does not have to have a work, but a work has to have an artist. There's no unknown artists. So here, I am going to say null here, but not null here. So that is my minimum cardinality that is allowing me to decide whether or not something is null or not null. Look here. Notice we've got nulls. We've got the minimum cardinality set here. So when I relate those tables, let's see, customer ID, I would write null here for customer ID. But let's look at this relationship. There's a transaction for a piece of work. Notice there's not optionality here. It's required. So when I create this foreign key, I'm going to say not null for that. And right here, I'm going to indicate that artist ID is a foreign key to the artist table. That wraps up the work table. And what I'm going to do is I'm going to create the data dictionary for each of these items and post it on Canvas.